just a little bit about Micah. He, so he's an augmented reality designer at Meta. He designs reality computing concepts for business applications that span the spectrum of augmented, mixed, and virtual reality. He currently prototypes user experiences at Meta Company, a Silicon Valley startup. Prior to that, he designed geospatial analytics software at Spacetime Insight, a company that combines data visualization and maps to solve large-scale problems that include transportation, energy, distribution, and project management. He's passionate about implementing Google Ventures design sprints and rapid research methodologies in every project possible. Micah studied cognitive science at University of California, San Diego, where he enjoyed surfing, skateboarding, and taking extra physics and robotics courses. So take it away, Micah.
All right. Welcome, everybody. I'm here to talk about Field of Dreams, Build Reality, and They Will Come. And I want to say thanks real quick to AJ Milton for making this a smooth call, and Amber Tedrick for putting the details on the website, Steven Sanders for making sure that everything was smooth beforehand, and Chris Erdman. It was really awesome meeting you, and I'm really honored that you invited me to share some of my experience here. And then the whole NC State University library and everyone there, actually, I kind of have an interest in this school. Before I joined Meta Company, I would use a website very frequently to inform my designs by Dr. Christopher Healy, and he's got some really neat perception work there that I really drew from. So it's really cool to be hanging out with you guys today, virtually, but in this room. All right, so I wanted to talk about some obstacles that exist to starting products and projects in reality computing. And when I say reality computing, it's kind of a misnomer, but it's easy to say. It just refers to AR, augmented reality, mixed reality, and virtual reality. So I think there's three obstacles. There's like, what's the vision, or like what's the end goal of it, and how do you get started with that? Like, do you need a headset to start, or is there something else? Like, what's the starting point? The second one is spatial design. So, like, I feel like humanity is pretty good at, 2D interfaces. We've got it nailed down, but now we're in the wild, wild west of how to design and code spatial interfaces. So I'll speak to that and give some practical tips to anyone wanting to start in it. And then third, code kind of was the bane of my existence, but now I feel more comfortable with it, and I'll share like some quick tips that either you guys can use, or maybe you have students who you're trying to stoke the flame of excitement for this new paradigm, and you can maybe share it with them. So I'll start with vision. Like, where do you start? Do you need a headset, or what if you don't even have access? Like, what if somebody, wasn't a part of an awesome university and they just had to use the public library and they only had an hour a day? Could they start, an hour a day access to a slow computer? Could they get into this industry? And I think, yeah. I think before we even think about what headset we're going to use, we should find a really exciting problem. We should find a problem that maybe you can't sleep a little bit at night because you think about it so much, or you have a PhD in it, and so you really are familiar with the problem and you are excited about it, or whether you're an undergraduate and you're just starting to think about things that are going to be problems in our world over the next couple decades and you want to tackle them. I think that's the place to start. And I think it's really important to then have a process to approach the problem. And I should probably back up and say that I think the problem should be shared by like 500 people or more, unless, it's like 20 people with a lot of money and they really like you and you're brilliant. Otherwise, it should be a significant problem that a lot of people have, so that you're really making the use of the resources of the company or the university who has headsets, and yeah, everybody involved. So this is a user experience methodology. It's called storyboarding, and well, I mean, it's not new. It's been around in film and tons of other places for hundreds of years. But I can make it sound new, and it's simple, and I think anybody can get started in it. So I want to share with you how to get from point A to point B in an exciting problem, one that I think a lot about, and that is, what if a company was an online company, and it was this marketplace where people bought like millions and billions of packages? And what if they had a fleet of awesome robots or droids, and they went in a warehouse and made life easy for all the human beings? Well, what if we wanted to go one step further, and that company wanted to deliver packages all throughout I can't even say that word, all throughout big cities in the U.S. Thanks for going easy. Well, I think that's a really big problem. It's a really cool problem, and it's actually likely to happen. So how would you solve that problem? Like, what if you're a person who's wearing reality glasses, and your job is to find issues with droids who maybe are a little rude? You know, things went great for a couple years, but now they're starting to maybe curse at people or pull pranks. They're just breaking down their software. Updates are getting really bulky, and you need to keep a really good PR for this company. So you've got to find the behavioral issues with the droids in the cities. So now I want you to use your imagination a little bit. The slide that you're looking at probably seems like 2D. Like, you probably just see some squares and a circle, and then kind of a weird white city. Well, imagine that you're looking through a window, or you're looking through glasses, and closest to you, the table is closest to you, that's the person. And then deeper in to that window is maybe the podium, and that's the city. So there's depth there. And so on the left, there's you wearing some glasses, which are overlaid right on top of that really strange looking circle. And let me back up for a minute. The whole point of storyboarding is not to make it look pretty or not to be good at it. It's to sketch really quickly. And so you can do that with pencil or paper and take photos of it and upload it and have people talk about it through email. Or you could use Google Slides, where you're just grabbing stuff and throwing it in a slide deck and telling the story and circulating that way. So here you are, you're looking at a holographic city, and the way that you're going to find these unruly droids is through a tree map. And this is one of my favorite data visualizations. I think it's really useful. And probably you guys are all really smart, so you probably know what a tree map is already, but in case there's one person who doesn't, I'll just define it real quick. Tree maps show hierarchical structures and attributes via size and color. So what I mean is, we've got this droid, and it's got these behavioral issues, right? Well, maybe it also is constantly above the legal limit of energy consumption. Or, maybe it's just not profitable. It's not a profitable droid, and you want to find these types of droids. The second thing that a tree map can do is compare multiple levels of categories, and it can reveal patterns. So maybe you want to go further than just finding the types of problems in a city where the droids are, but you want to know where in the city these are happening. So you could just look at the behavioral section. You just draw some white lines, cut things up, and then if you see a bigger area within a square, you'd say, oh, within region 2, there's this really big issue going on. So the next step in the storyboard is to say, okay, you're looking at the tree map, and now you see places in the city corresponding to the categories on the tree map. And then what the user would do is reach up and highlight just the behavioral parts, because that's what they want to see. And so you begin to see other aspects of the UI of the tree map fade away. Now you're just looking at the behavioral parts, and on the map you just see the areas highlighted that relate to behavioral issues with droids. And one far thing that I was thinking was, well, what if the tree map then lost its sense of scale and actually started to become the city, and the actual holographic city kind of like faded away? So I was just kind of toying around with that idea, and this is fun because you can toy around with ideas just with pencil and paper or with Google Slides and invite people to it, and they can say, yeah, that's a good idea, or no, you should try this approach. And then the final part is, hey, this guy is now immersed in the city. Like, he's walking through a holographic city, whether it's an AR or MR or VR. He's looking for this one really intense drone that causes a lot of issues for a lot of people. And if he solves this problem, then he can really make an impact for this large company. So he's hoping to find the droid that he's looking for. But these aren't the droids. Okay. So I'm not going to quit my job and become a stand-up comic, but try to make it a little fun. So another point in storyboarding, and before you even design or before you even code, I feel like, is asking for help. I think you should come up with the solution that you really think could make a big impact, and then go to people who are experts in their field, people who have solved problems, and show them, and they'll be your biggest, they'll back you up, and they'll shoot holes in your ideas in a loving way and help you iterate the idea so that your project can be a huge hit or a big success. I think that anybody who has already storyboarded and has already been thinking through some of these problems, once they've talked to some experts, I would go on and do some research. I think some great places to look are some spatial principles that my CEO has created. You see, there's some really cool ways of approaching design. And also, my neuroscientist at Meta has been linking like user interface best practices and actual neuroscience so that it's super easy and intuitive to use. So that can inform even if you're designing on VR. And I'll show you some VR work that I've done where you can use these. So enough commercials. The next, they're really cool links. They're really great talks. So the next obstacle that I see is spatial design. Like, hey, how do I go from 2D to 3D? How do I translate? And we've gotten so good at making web applications and websites and anything and everything, and we have multivariate testing methods. We have heat maps. We know where somebody's going to be looking, and there's some interfaces that update themselves based off user interaction, and it's pristine and beautiful and almost like cultish how refined everything is in the 2D paradigm. But things get more complicated on an order of magnitude when you start to design for 3D. And I'll highlight what some of those things are. If you look to your right, you see some holograms just represented by boxes, and you see some shadows cast. And it looks like there's like a light source to the upper right kind of behind them. And one problem you might have is, well, what happens when I have light casting a shadow through my holograms, through what I'm seeing, but then there's light just around me, not connected to my headset, and it's causing shadows to go in another direction. That might like really mess with your mind. Another thing that you have to look out for is occlusion. Like, it's so easy to know in 2D where the content should go because we have a heat map that measures where people spend most of their time looking. But where do people spend most of their time looking in this plane? And where in that plane do they look, or in the plane after it and after it? And what happens when you think some information is important, but you block it? Like, for example, you can't really see which square is number 2 and which square is number 3. And that kind of relates to how you would put a label on an object, just for something like marketing or advertising. So there's some really big questions, and I think it can be overwhelming sometimes to get started in designing 3D applications. Like for example, data visualization. How would you make an information dashboard, or would that even be a good idea? Like, what would you make a giant pie chart? Um, I don't really like pie charts, so I wouldn't do that. But there's a lot of questions left there. So my solution to that is take design risks. Like, just throw caution to the wind and get going. And so I want to share like a virtual reality application that I made where we took design risks, we iterated quickly, and it came out to be a lot of fun, and I think it was a really cool project. So this guy I know, Shiv Kumar, he's an engineer here in San Francisco, pitched this idea of a music app where you can just experience painting sound in space and seeing the changes and hearing the changes uh, with the object as it moves through space. So I'll play this video, and what you probably can't hear is Queen playing in the background. I'll just mute it because it's probably not going to sound right. But just imagine you hear like a Queen song playing, or imagine you hear your most favorite song playing. And what we did was we took just the vocals of your most favorite song and we put it on the sphere. And then we took the drums and put it on another sphere, so on and so forth. And then we enabled you to move around the room by clicking, and then you can just throw the music. And as you lift it up, you hear it more loudly in your ear, but just like the vocals. And then you throw them, and everything changes. And it's really a fun, playful, cool experience. And if you were a design guru, you would see a lot of holes in what we made. Also, I wanted to mention Nate Black, another engineer on this, and like super helpful to building it. I just didn't want to leave him out. And let me go to the next slide. So I said take design risks, and like what I mean is look at this UI. This is the palette, and it's not superb by any means. Actually, it kind of just gets the job done. There's only two options here. You can take a track and throw it, or you can erase something. That gray sphere in the background is an eraser. So it's not complex, doesn't have a lot of buttons, and it hardly took us any time. I really encouraged them to make the simplest thing possible so that we could focus on the major vision. And then Shiv really took that to heart, and then he came up with the erasing feature. So you don't see buttons, you don't see like undo and play and pause and the myriad of other options that would be available, and that's on purpose. One, because it's implicit. A lot of the things are implicit, the things that you actually have to do. And two, we just didn't see the need to do it at the time because we wanted to see if the idea was good in general. And so I think, if you're going to have students come in and begin to conceive of concepts, or if you want to start a project yourself because you've got something really cool you're doing, you can actually validate your idea really quickly with no design and no code. All you have to do is think outside of the box and not be willing to look ridiculous. So we wanted to see if the idea was any good at all. So what we did is one of us put the vocals on our cell phone and ran around me. The other guy put like the drums on his cell phone, just the track and nothing else, and he ran around me. And then we kind of took turns standing in the center, running around, and we noticed, you know what? There is totally a difference in the sound and the way you experience it. And if you close your eyes, it was so fun, so incredibly awesome. So we decided to take that to the next level and see, well, hey, what would this look like if you were in it? So we put on an HTC Vive and we just mocked up in Tilt Brush and basically made a wireframe. So what we did was we said, okay, here's this sphere at this position when you get in, and then the next stage is you've picked up the sphere and you've thrown it. And so we just drew it in a static, stuck way, and we just showed 4 steps through the application of what that could feel like. And then we had people just come in and try it, people who weren't in our project, and they found flaws, and they suggested doing things different. And if we hadn't invited them in, we might not have made what I think is like a really cool app. So this works if you are doing graduate work and you want to get like professor feedback or stakeholder feedback, or this works if you are trying to sell to like Fortune 100 executives. You invite them in, they put on the headset, and they get to become the designers and offer suggestions, and they can paint. And I think if you put your stakeholders in control, then you're going to be setting everyone up for success. So then, let's learn to model. I mean like 3D modeling, not actual modeling. I don't have any experience in that. But if you want to get started with modeling, go to blender.org and download this free application. It's amazing, it's free, and you can do everything that you can do with Maya or 3ds or any other software suite that is well worth the money but costs some money. This is free. So you should go and download this, and while you're waiting for it to download, you can go get yourself some holograms. They're just 3D models, and you can get those from TurboSquid, and those are free if you use the filter at the top. So first you would like create a profile, sign in, costs nothing. Go here, select the drop-down box, just enter in 0 for max, and then take a look at the editorial and license issues. So if it's going to be a public-facing project, you might just want to know what you can share and what you can't, so that everything is smooth for you and nobody comes asking you for money once you've made something amazing. And then the last thing is the formats. If you want to just put them right in your development environment, then I suggest using an FBX file format. Don't worry about what the names of the format file means, just FBX is probably what you want to use. There's some other ones you can use, but you'll have the most success with that, I think, right out of the gate. But let's say you're on TurboSquid and you find like the best model that you think is going to make this superb hologram, and you want that. Well, that's cool. You could probably do that. Blender's probably done downloading at this point, so you can go to the file menu, just import, and then here's a whole variety of options that you can import from TurboSquid. And they have a lot of these up there. Most of them are supported. So then navigate to the file, wherever you put it on your computer, and then put here's the elephant in the room. That's another bad pun. I realize they're not funny, but hopefully they keep things lively for you. So then you can just export that as an FBX, and you'll be ready to drop that in your development environment. And now you know how to get holograms going. So the last part of the 3 obstacles that I've ran into is coding. Like, how do I learn how to code? What if I studied English, but I'm just really taken aback by how amazing holograms are, and now I want to learn to make these for myself? Then you can do that. There's some tools out there for anybody with any background to come in right away and within a few hours walk out the door able to make actual virtual reality applications, which are a precursor to making augmented reality applications. So if you wanted to do this, I would recommend that you go download Unity. Unity is a development environment, and it's not the only one. It's not web-based. It's a packaged software that you download on your computer. A lot of companies use this, like Oculus, Meta, HTC. They use this to produce the content. There's other ways. There's web applications. There's APIs that are just JavaScript only, and you can use those. That's fine. But if you just want to get going within like 3 or 4 hours and make something, this is the way to go. So there's a free download option in the lower left. And I would start with this rollerball tutorial. If you've never coded before, you could do this thing probably in 3 to 4 hours. And you'll know how to use Unity. And that's cool. Now, if you're like, that's okay, but I want to start making virtual reality right now, then you can actually get a free week of Udacity, and you can actually build your very own like virtual reality Google Cardboard application. So I would just be very thoughtful about when you want to do that. Like, look on your calendar, set up the weekend that you want to do it. It'll probably, if you've never coded, it'll take you 4 hours maybe. If you've coded before, it'll just take like an hour and a half to do it. And sign up. You're going to get 1 week, so use your time wisely. I would go right to the Hello VR World. They have so many videos that it's like it doesn't take a rocket scientist to do this. Like anyone could do this. Um, so yeah, go in. You'll make it. This is just kind of a quick preview of what you're looking at. They give you some UI buttons that you can look around at and activate, and it makes some cool particle effects come out of a box. You learn what the development environment is like, and you get really comfortable. And so I liked it so much. I'm almost done with it. It's the Udacity VR Nano Degree program. And so the second to last project I've been working on is just a gallery of where things are, the current state of virtual reality, and where I think they'll go. And one thing I did to make it, like for code, was just grabbing some stuff they gave me in a previous project that toggles things on and off. And I put this script literally on this UI, and so when you look at it and you click, it just toggles it off. And then I just started putting that on everything and prototyping. And if you had an engineer look at it, they would laugh and they would say, "This is a terrible design pattern. Don't ever do this." But if you're just getting started, it works. So that's like the 3 obstacles that I've experienced in the last couple of years getting started, breaking into reality computing, and then I think that anybody, whether you're a high school student, you never got an official education, and you're 50 and you just want to start doing this new thing, or you have a PhD in neurophysics. Well, I think that these 3 things would help you. Be it starting with storyboarding, finding a problem, storyboarding it, and then asking people questions. Thinking about the differences between 2D and 3D design, but then just throwing caution to the wind and saying, "I'm ready," and taking risks. And then code. There's a couple resources here I think that will be very helpful to anybody. So lastly, I'll leave you guys with a challenge. Anybody who wants to take a next step in reality computing, I would recommend that you go public, fail publicly, show people like what you're doing by storyboarding a reality solution and writing a Medium article about it, or adapt a model in Blender, or complete the Hello World and import a model, or do them all. Like if you could do all those 3 things, you would that would be a really great experience, and then you can share it on Medium and interact with other people who have written stuff, and then they'll come and react to stuff that you write. If you mention me, then I will come check out what you've made and ask you questions about your ideas and have fun and go from there. So that's everything from my end. And if you guys have any questions, I'd be happy to answer.